Okay, today's episode is a reasonably short one, but it's about calculating final velocity, so very exciting stuff. Let's say we're on the moon and we want to drop something from shoulder height, and we know that it takes 2.5 seconds for it to hit the ground. Then we know an acceleration is 1.6 meters per second, just because we measured it, and that should be meters per second, sorry. And velocity final is, of course, x meters per second. So how would we deduce final velocity? Well, assuming our initial velocity was equal to 0, then we could use this formula. Final velocity equals acceleration multiplied by time. So we just substitute in our values like we deduced before, 1.6 meters per second squared for acceleration and 2.5 for time, and then we'd be able to deduce what the final figure is. So now we just need to do a bit of long multiplication to be able to work it out. So what's 16 multiplied by 25? So 6 times 5 is 30, carry the 3, that makes 80 there, whoops. Then we have 0 carried down. 6 times 2 is 12, carry the 1, makes 3 there. And essentially we get 400 from that. So because we have 400 from that, we basically write in 4.0 meters per second shall be our final velocity. And just to check, we need to do a significant figures check. And this is the first time I've done it, but I'll just show you what to do. Essentially, we used 2 significant figures here, and we used 2 here as well, so we're able to present it as 4.0 because that's to 2 significant figures. I will be doing a video about significant figures, but essentially we can't be any more accurate than the figures we started off with. Otherwise, it's a bit of a fallacy there. But again, I'll go through that in another video, but essentially it's always good to check and get in the habit of checking that you have the right number of significant figures, so you can't be more accurate than the data provided to you. But now you're probably asking, well, what do we do if the initial velocity is greater than 0? In this example, we basically just calculated from standstill how fast an object would be traveling when it hit the ground after 2.5 seconds. Well, let's say in this example that we have an initial velocity of 20 and that we have an acceleration of 2 but the same time of 2.5. It's really simple what we do to the formula. We just add initial velocity into it. So final velocity equals initial velocity plus a multiplied by t, and whoop-de-doo, we're able to get an answer from that. Initial velocity of 20, we then do 2 lots of 2.5, and of course that makes 5, so we get 20 plus 5, 25. And when we give our answer, it always has to be 25 meters per second. Now, there is one last thing that I'd like to say, and that is because we're working with velocity, which is a vector quantity, we need to clarify direction. So it's traveling basically 4 meters per second downwards when it hits the surface of the ground, and this one's traveling 25 meters per second downwards if it were in a similar situation, but with a much higher initial velocity. Now, I have done videos on initial velocity and final velocity before. I'd recommend that you watch them, just search for them and search for videos by Fun Physics Assistant, and you should be fine in case you don't understand these concepts. But this is essentially the formulae that we use to be able to calculate final velocity. There will be more videos about this with more complex examples, such as dropping stones off a bridge, and we'll also be looking at forces and Newton's laws and things like that in future videos. I hope this was helpful, and again, it's just a simple equation of motion involving initial velocity and the acceleration of an object. Thank you.